Why time only moves forward. Entropy and the arrow of the universe. Time, entropy, and the arrow of the universe. Imagine living in the 1700s on the Mediterranean coast, watching the sunset from your window. As night falls, waves crash onto the shore, sand piles up irregularly, and you light candles to keep working. Now imagine stopping the sunset, or even reversing time itself. If time flowed backward, the sun would rise instead of set. Waves would retreat back into the sea, and bubbles on the shore would vanish as if they had never existed. Everything would look deeply unnatural, as if the fundamental order of the universe were being violated. But if time rushed endlessly forward, the opposite would happen. Waves would endlessly erode the land, buildings would turn to dust, stars would burn out, and eventually nothing would remain. This destructive one-way behavior of time is driven by entropy. Entropy and the arrow of time. Entropy is the tendency of all systems in the universe to move from order to disorder. It always increases. This irreversible increase gives time its direction, known as the arrow of time. In daily life, entropy explains why rooms become messy if left alone, ice cream melts, iron rusts, food spoils. Even when we clean a room, entropy does not decrease overall because the energy we use generates heat and increases entropy elsewhere. On a cosmic scale, entropy causes stars to explode and even black holes to slowly die. Time flows forward because entropy increases. No system can resist it. The origin of time. Ancient thinkers debated whether time had a beginning. Aristotle believed the universe had always existed, meaning time stretched infinitely into the past and future. Christian theologians, like St. Augustine, argued that time itself was created by God, so there was no before creation. Modern science transformed this debate in the 20th century. Relativity and the expanding universe. With Albert Einstein's theory of general relativity, space and time were unified into a flexible structure called space-time. In 1929, Edwin Hubble discovered that distant galaxies are moving away from us, proving that the universe is expanding. This led Georges Lemaitre to propose the Big Bang theory. The universe began from an extremely hot, dense point. Evidence, such as the cosmic microwave background radiation, strongly supports this idea. At the very beginning, called a singularity, space and time had no meaning. Time emerged together with space when the universe began expanding. Time travel and paradoxes. Because space-time can be bent and distorted, general relativity allows theoretical solutions involving time travel. However, traveling backward in time introduces paradoxes, such as the grandfather paradox. If you travel to the past and prevent your own existence, how could you have traveled at all? Some theories resolve this by proposing multiple timelines where changing the past creates a new, separate reality. Still, backward time travel appears to violate entropy and the second law of thermodynamics, making it extremely unlikely. Time dilation, traveling to the future. Traveling forward in time is not only possible, it already happens. According to Einstein's special relativity, time passes more slowly for objects moving at high speeds. Astronauts aboard the International Space Station, traveling at about 28,000 kilometers per hour, age slightly less than people on Earth. This effect has been measured precisely using atomic clocks. Time also slows down in strong gravitational fields. Near massive objects like planets or black holes, space-time is curved and time passes more slowly. Even your feet age slightly more slowly than your head because they are closer to Earth's center. Black holes and extreme time effects. Black holes warp space-time more than any other known objects. Near a